Hello everyone, I'm Shine. This video is for EL6303 probability and stochastic processes. I'm going to explain the 7th and 8th problem in homework 7. Now let's do the 7. Given the stochastic processes ZT and N1T and N2T are wide sense stationary processes, and N1T and N2T and theta are all independent. To find these three parameters. So let's do the first one. To find the mean of ZT. We know N1T and N2T are wide sense stationary. Based on this definition, we get each mean of N1T or N2T are equals to a constant, and so here we can assume the mean of N1T is eta 1, and mean of N2T is eta 2, and they are all constants. So here I can write the mean of ZT equals this form, and then I write this formula as a sum of two means. So in the first mean here, we know N1T, mean of N1T is a constant, so I can write it out. So here, and do the same as N2T. So here, I can write here the mean of N1T is eta 1, and mean of N2T is eta 2, and the mean of cosine function here is computed by its definition, and so does sine function. And we know cosine function, the sine function is a periodic function in the 2 pi interval. So we know its mean will both equal to 0. So we get the final mean of ZT is equals to 0. The second question, to find the autorelation of the T1 and the T2. So by definition, RC T1 T2 equals to the mean of ZT1 multiplied ZT2, and I expand this expansion, and so I got this formula. Here I know will it appear N1 T1 multiply N1 T2 by since N1T and N2T are wide sense stationary, by its definition, I can get this expression. Mean of N1T and N2T is equal to autorelation of tau. Here tau equals to T1 minus T2. So I can write this formula as this. Here are two autorelation, and the others are multiplication of N1 and N2. And from this formula to this formula, I use the four sine functions formulas to transform multiply of sine function to sum of sine function. So here this term is cosine multiply cosine. This is sine multiply sine, and this is cosine multiply sine. So these four terms are all used. These four terms use these four formulas to get this expansion. And then I write the mean of cosine function as its definition. It's integral on the interval 0 to 2 pi. As the same as the previous problem, the integral of sine function will be 0 because it's a periodic function. So here, this term are all equals to 0, and finally I get this only term. So here, this is equals to autorelation of z. So since our autorelation T1 T2 equals to our autorelation of z of tau, so process zt is wide sense stationary. The third question to find RC0. Here RC0 is equals to here tau equals to 0 and tau equals to 0, and here tau equals to 0. So it can write as like this, and then Rn10 is equals to the mean of n1t multiply n1t minus 0. It's still n1t squared, so I can get the final result here. Let's focus on the eighth problem. Given the Poisson process and all details about that, and its three properties here, and to find the mean of xt and the autorelationship are T1 and T2. So let's focus on the first small question to find the mean of xt. Considering the Poisson distributed random variable, here the probability of x equals to k is like this form. And in homework 4, the 7th problem, we get the mean of x and the mean of x squared. The details are here. We know its formula and do the simple derivation, and we get the mean of x is equals to lambda, and using the similar method get the mean of x squared equals to 1 plus lambda, then multiply lambda. So we can derive from this Poisson distribution to get the Poisson process. In Poisson process, mean of xt equals to lambda t, and the mean of x t squared equal to 1 plus lambda t, and multiply lambda t. So this is the mean of xt lambda t. The second problem to compute autorelation of T1 and T2. So by its definition here, we get it. This is mean of x T1 multiply x T2, and here we use one of its property. The second, if the intervals T1, T2, and T3, T4 are non-overlapping, then the random variables n T1, T2, and n T3, T4 are independent. So here we can write the xt1 as xt1 minus x0, and x2 T2 equals xt2 minus xt1, and plus xt1. So here, since x0 is equals to 0, so here is xt1 multiply this part and expand each, and here I get it's mean of xt1 multiply mean of xt1 multiply mean of xt2 minus t1. We can write as this form because these two parts are independent, and then multiply plus the mean of xt1 squared. Then we can write here mean of x1 is lambda t1, and this part is lambda t2 minus lambda t1, and this part is 1 plus lambda t1 and multiply lambda t1, and together it's simplified form. And these whole processes are based on t2 larger than equal to t1, and we can consider the inverse situation when t1 larger than equal to t2. It's a similar formula. So here we can get the autorelation of t1 t2 equals to, here we write as the minimum of t1 or t2. So this is all for homework 7. That's all. Thank you.